The high voltage battery is the most complex but also the most dangerous object inside an EV or hybrid electric vehicle. So the question is, how can we do easy to understand and safe training on such a thing without any liability risks? The answer is the CarTrain high voltage battery diagnostic and maintenance. So what do we see here? Basically what you have here is a complete high voltage battery, which you see to the right hand side. We have here 16 lithium iron cells, original ones. Nothing is fake, nothing is simulated. You have a real high voltage battery running inside that system. But of course, it is a training system. It is a trainer. That means everything is designed that way that it's completely student safe. Even if the student is doing something wrong, nothing will happen to the training system and nothing will happen to the student. The 6 lithium cells are just connected in row with each other and you can completely disassemble it. That means in order to gain the highest qualification level for the different curriculums all over the world, so for example, the trainer as well as the e-learning curriculum, it is aligned to the ASE curriculum in the US, to the German curriculum, the DGUV, and furthermore to the IMI curriculum, which is suitable for the UK or other international countries like Dubai, Asia, and so on. Like I said before, the complete high voltage battery can be disassembled. Why this is so important, we will see later when we do the different diagnostic jobs on the battery. But at first, let's start the car. What we see here is the complete drivetrain of an electric vehicle. What do we do with that? At first, we start and boot the high voltage system. How are we doing that? We push the brake button and we push the ignition switch. Now the system boots up and as we see here, we are ready to go. Next thing is we start the driving simulation. So what we can do here, we can simulate 5 different driving situations. We will start with driving uphill, driving in flat terrain, doing the coasting, and then we have 2 modes where we can simulate the downhill mode, speaking of regeneration or recuperation. What do we see even more if we want to have a more closer look inside the high voltage battery? We have to use our diagnostic tester. And this is where our e-learning curriculum comes into the game. So that means this is like a one-stop solution for the whole topic for working on high voltage batteries. And integrated is a complete diagnostic testing unit like the car manufacturers are using it. So let's see. We start instruments, tester, and here we go. We have here the complete diagnostic system. But before we go closer to the diagnostics, I put on my safety glasses. Safety first, of course. So let's see what we can do here. We jump now to the high voltage system, system values, cell voltage monitor. And what we see here are the single cell voltages in real time. And when we change something with this driving switch, we see directly a change within this cell monitor. So for example, right now we're driving downhill and we do the regeneration. What we see here is now that electrical energy is flowing into the high voltage battery, and that of course on both sides. When we go back to the coasting mode, what do we see here? It's 0. What does it mean? There is no energy going in or out of the high voltage battery. Completely different when we are driving uphill, what we see for example in that mode. Now we see that in that case, round about 4 amperage are going out of the battery. So there is a load on the high voltage battery and the battery gets discharged. The most important point is now, when we are talking about the hybrid electric vehicles and what we have seen before by analyzing the high voltage battery, in that case we are talking of a vehicle which is in a good state. But what is if there is a vehicle which was previously involved in an accident? There we have got a big problems and a lot of people in this change who are involved in working with these systems or with these damaged cars have to be trained to a certain level. And this starts with the firefighters, for the first responders. And even our training system is equipped with certain things which makes the firefighters able to understand what is important about hybrid electric vehicles if they have to deal with it. First, it starts with the rescue cards. The rescue cards are inside our e-learning curriculum. But furthermore, and much more important, are the single components which are part of a high voltage system inside the car, which are specially designed for firefighters, for example. So if we have a look at the system, we see this is, for example, this fuse over here. With this fuse, we can directly deactivate the high voltage system when we pull it out. Similar to that, we have our 12-volt service disconnect. If the firefighters are pulling that out, the high voltage system is disconnected too. But it's not only about the firefighters, it's also about the tow truck drivers. When they put the damaged vehicle on their truck and bring it to the workshop in order to repair it, they need to make sure that they know what's going on with the car in spec. Just imagine you are stuck in a traffic jam and suddenly the high voltage battery catches fire. That's a disaster. Furthermore, when we arrive at the workshop, there everything is about the guy who's responsible for the workshop. This guy in the workshop must have the highest qualification for high voltage because he has to decide what happens to the car. But in order that he can decide what he should do with it, he has to understand if the car has a critical or a non-critical fault. How do we find out that? This is where we use the car train again in order to create this absolutely necessary diagnostic competencies. How are we trained that? No problem, have a look inside the e-learning curriculum. We just shut down the car before. So what we have inside this curriculum is a complete section of diagnostic work. Within the e-learning curriculum, we have more than 23 different job orders. And the very good thing about that, these are faults which are directly integrated in the high voltage battery. That means you have nothing to do on it, just click on the page and the fault will be active inside the high voltage battery. With another click, you can directly delete it and the car is good again. Just think about doing that to a real vehicle. That would mean you have to open the high voltage battery and you have to put in faults inside the high voltage system. That means you have to manipulate the complete high voltage system. All your guarantee, all your assurance stuff will be gone. No one will be responsible for that except yourself. And just imagine such a modified vehicle will catch fire. If you modify such a hybrid or electric vehicle, the complete responsibility is at your hands. Therefore, it's much better to use our trainer so you get rid of all the liability risks. Here, everything is designed and developed this way that a student can work on it. And even if he's doing something wrong, also in the diagnostic part, nothing will happen to the system or to the student. Win-win situation. Let's go back to the job order. Now we will do, for example, job order 1. So we're just jumping inside this folder, click on it, and there the fault is activated. Okay, what kind of fault do we have now? Let's start the car again. We start the car. And we see now there's directly the high voltage fault light is active. So it means something is wrong. And there's another thing which we can see. Also the fan for cooling the high voltage battery is running. So we can assume that there is a fault which is related to a temperature issue. In order to find out what kind of temperature problem we do have here, we will now start the diagnostic tester again and read out the fault memory. So we go to Instruments, Tester, and we're just inside our tester. Step forward, high voltage system, fault codes, read. And there we see with the original fault code P1A32, battery temperature abnormality. So that means we have an abnormal temperature situation inside the high voltage battery. Now we are at the border where we have to decide if it's a critical or non-critical fault. Why is that so important? if we really have a temperature issue here, that would mean it is critical, because then the battery can heat up and it can possibly catch fire. On the other hand, it would be a non-critical fault when the problem lies inside the sensors, for example, for the temperature monitoring of the high voltage battery. In order to find out that, we have another look at our temperature monitor. So we leave the fault code reading, go back to system values, and now we open the temperature monitor. What do we see here? We see now for each single temperature sensor the measured temperature. If we have a look at the monitor, we see on the left bank everything is fine. We round 27 degrees. On the right hand side, we suddenly see that temperature sensor 2 shows up a temperature of minus 40 degrees. What does it mean for us now? We are all aware of that this is not a normal temperature. So at first, let's locate where the sensor is. We have here T1, T2. That means here we have the temperature sensor, which is obviously faulty. So what does this temperature tell us now? At minus 40 degrees, no fire will start. But we can say it's a non-critical fault at that stage. Why can we say that? Because it means that this NTC temperature sensor has something like a disconnect or interruption inside the wiring or inside the sensor itself. This is why it shows up to minus 40 degrees. Now we know that this is a non-critical fault. That means we can bring the car inside, or we can let it inside the workshop, open the battery and repair it. In order to open the high voltage battery, we have to shut down the high voltage beforehand. And I will show you now how we can do that on that system as well. This system uses a very modern way of shutting down a high voltage system by the help of the tester itself. So we navigate back to special functions, and there we have high voltage isolation procedure. And this is exactly what we want to do now. So we click on that, there are certain warnings, we can run through it, and now it tells us to switch on ignition, not to ready mode. That means we switch off the system and just turn on the ignition. Now we go one step further so that the system will go into the self-testing mode. And this is what we see now here. High voltage system is active. That means the electronic inside the high voltage system measures the actual or real-time voltage of the high voltage system. And right now we are still in the high voltage active state. So next step, switch off the ignition. We will do that. And then it tells us disconnect the green 12 volt service disconnect. Which service disconnect is that? Of course, this one over here. What are we doing? We just grab it, but stop here. Do we need to wear any gloves? Like this? No, we don't need to wear these gloves. We can get rid of that because we are here not in the high voltage system. This is just a 12 volt system, therefore no need for gloves. I can do it with my bare hands. So just go here, open it. Now it is pulled out, so the high voltage system got a signal to disconnect itself, and now we have to secure it that no one else can put it back into operation. This is why we use this padlock. We put it through the hole, we lock it, and of course we keep that key inside our pocket. So now the system is disabled. Before we can be sure about that, the system has to do a last measurement and to tell us that the high voltage system is safely shut down. So we go to the next step, switch the ignition on, and now we see the high voltage system is de-energized. This is the point where we know that the high voltage system is shut down and we can work safely around the high voltage battery. Beware, not inside the high voltage battery. We have now done everything in order to get the high voltage battery out and to open it. But the high voltage battery always remains high voltage. This is why we need to wear Always the PPE as soon as we go into the high voltage battery and work inside the high voltage battery. Now we have shown how to deal with a non-critical fault. Next step will be to show you a critical fault. This is where we switch to job order 19. So 19 tells us short range. We just open the folder and jump to diagnostic procedure. So that means, again, the fault is now injected directly into the high voltage battery. What kind of fault we have now, we will find out. At first, let's start the system. So we boot up the system again, but what we see here is ready mode. Okay, the car has not found any fault so far. So next step will be we have to go back to the diagnostic tester and read out the fault memory. So we go to, again, to instruments, tester, and then to our fault reading, fault codes. And we read out the faults. But even here, there are no faults. So what does it mean? Obviously, we have a fault which is only or can only be detected while driving. So let's go for a test drive. We start the car and just drive uphill. Right now, nothing happens, so let's use the time in order to jump back to the voltage monitor. Right now, you have seen he has now caught the fault. So the high voltage light came on, the fan came on as well, and it has detected a fault right now. So let's see what the temperature will tell us now. Or we can even go back to the fault monitor and see what the faults are there. So we read out, and there we see now we have the fault. P1A30, cell error, voltage low. What does it mean? We will check now in the voltage monitor. So we go back to system values, cell voltage monitor. If we have a look at the left bank, we see everything is okay. All the voltages of the single cells are around 3.5 volts, so that's pretty good. On the right hand side, there we see, even indicated through the red light, one of the cells is out of range. And there we have, instead of 3.4, we just have 3.06 volt. This is much too low. And what will tell us that? That there is a too high resistance in this cell. In the cell, or even around it in the connections between the cell and the rest of the high voltage battery. What would be the next step? Now we have a critical fault here. Could lead to any further problems, so we definitely have to repair it. That means the car has to go back into the workshop. We have to shut it down. And then we have to shut down the vehicle again, put on our PPE, and then disassemble the complete high voltage battery, and we have to swap the cell. The broken cell, in that case, it's cell 6, and this is this one over here. So this cell is in that case broken and needs to be changed. When everything is fine again, the teacher or the student just delete the fault again, jumps back out of from the fault page, and everything is fine again, and the system is put back into normal conditions. What we see here now is that we have a perfect training system for students who want to become a high voltage expert. With this training system, you learn everything which you need to work safely inside the high voltage battery, or even to work around damaged hybrid or electric vehicles. And when you have once fulfilled these requirements and worked through all these job orders, you have the right diagnostic competencies to work on a real car, and you have fulfilled the highest level of training.